enough water is frozen in the East Antarctic ice sheet which, if completely melted, could raise sea levels to almost 174 feet. Previously it was believed that the ice sheet was much more stable, especially compared to its cousins, the ice sheets of West Antarctica and Greenland. But a study published last Wednesday in Nature found that it is more vulnerable than scientists thought. As with much of climate science, a window into the past may reveal clues about our climate future. The ice cores document hundreds of years of snowfall history, revealing the rapid increases in snow that are observed today in parts of the world. A strange period in the history of megadroughts helps us to understand the probability of a widespread drought today. And now, the history of glaciers in East Antarctica obtained from mud samples, ancient pollen and marine seismic technology shows us the potential instability of the future of glaciers. It turns out that for much of the history of the Eastern Antarctic ice sheet, it was not the large stable ice layer commonly perceived with only minor changes in size over millions of years, Sean Gulick, lead author and geophysicist and researcher of geological sciences at the University of Texas at Austin, said in a statement. Rather, we have evidence of a very dynamic ice sheet that grew and decreased significantly between the glacial and interglacial periods. There were also often long intervals of open water along the Sabrina coast, with limited glacial influence. Scientists from several universities used marine seismic technology deployed from an icebreaker to reconstruct how glaciers have changed over the past 50 million years along the Sabrina coast. They also collected mud samples 3 to 6 feet below the seabed and ancient pollen. Their findings revealed that the basin has been retreating and advancing several times in its history, at least 11 times in the first 20 million years of its history. At the beginning of its history, the ice sheet also had more thaw water on its surface, which can cause valleys in the tunnels, eroding the rock under the ice. These markers of instability occurred when atmospheric levels of carbon dioxide were similar or higher than current levels of carbon dioxide.